So my name is Jason. I run a company in town called Panopta. We provide infrastructure monitoring as a service. So basically what that means is our customers pay us to watch all their infrastructure, whether it is things that are publicly accessible like websites and mail servers, or things that are running inside their data center or inside their cloud environment like database servers, application servers, Kubernetes clusters, and things like that. And basically we continually watch these, gather all sorts of data about it, and we're the ones that, if you happen to be a customer of ours, wake you up in the middle of the night when things explode, and hopefully give you some data and some tools to help better manage your infrastructure. But namely, we're the ones that wake up when there are problems. So our whole platform is all based on Python. We have a tiny bit of C# code that we need to support Windows platforms, but aside from that, everything else is Python. So I'll kind of walk through a little bit about kind of some interesting use cases that we've got for Python right now. Basically, the whole flow of what we do is we're collecting data from all sorts of different sources, both running inside customers' environments and running in our global network of machines, pull that together, analyze it, and then decide, is this a problem? Do we need to alert somebody? And then also route that to dashboards and reports and things to help our customers do a better job of managing their infrastructure. So the first part of that is we have a global monitoring network, so we have a distributed system running in about 50 locations around the world. These range anywhere from in big points of presence, Chicago, Dallas, the Bay Area. Could be clusters of a bunch of bare metal machines. In smaller locations, like in Cairo, we have one small virtual machine in some data center that we've never seen before. So it kind of varies quite a bit based on what the customer demand is for different geographic areas. But these nodes are all running monitoring software that we've built, all in Python, that check for about 45 different types of network services. So basically, basic things like ping and HTTP checks, down to more esoteric, every email protocol and things like that. So all this is written in Python. We definitely leverage the batteries included part of Python to get a lot of the building blocks to use for this, and then augmented that with a lot of custom code to do kind of deeper inspection of what comes back. So if we're doing like we use requests to HTTP. Don't want to just show the stack trace that comes back from requests. If there's a problem, we're actually kind of parsing that, extracting as much information as we can out of that, and then rolling that up to display to customers. This part of our infrastructure actually uses a really heavy use of Python threads. So this is actually a use case where the global interpreter lock is not a problem. We typically run somewhere around 200 threads simultaneously that are doing all these network checks because it's so I/O bound, and the threading model actually works pretty well here. So not a lot of other places where the threading works well in Python, but this is where it does. Our core infrastructure, so we're collecting all this data, we're pulling it together. So we have a bunch of different sort of components and frameworks that are providing dashboards, providing a REST API that our customers use to automate working with our system. A bunch of internal apps that are written, a lot of them are in Flask. We have one that is, I don't know if anybody still remembers the Turbogears Python framework from quite a while ago that we still have running. We do a lot of asynchronous task management and using Celery and Redis. And then again, we have a lot of custom either multi-threaded or multi-process servers that are actually doing all the data processing for everything we collect. And then eventually shove all that into either a MySQL or an influx database for data storage. We're actually starting the process of transitioning from a very database-centric architecture to more of a streaming model. So we're starting to roll out Kafka and looking at a streaming framework called Wallaroo to do the actual stream computation on top of that. So that's one of our big projects for this year. So as everybody else has mentioned, we're always looking for good developers, so if you want to get into stream processing in Python, definitely come talk to me. Another piece that we have that is also all Python, we have a monitoring agent that we basically give to our customers to deploy on their servers that will gather system information and push that up to us. This is one of the more challenging parts because the customers we deal with typically are big enterprises or big service providers that have a lot of legacy infrastructure. So everybody is talking about moving from Python 2.7 to one of the 3.7 or one of the other versions. We still have a lot of customers that are running Red Hat 5 machines that have Python 2.4. We had one prospective customer that had this giant network of legacy machines running Red Hat 3, which I think had Python 2.3, and we told them that wasn't going to work. But we have one code base that supports all these platforms, so we're kind of writing, at least with the agent code, sort of lowest common denominator code. So you lose a lot of the structures that programmers are used to working with now if you're supporting 2.7 or 2.4 as well. The other challenge that we have is we're deploying this as essentially kind of an untrusted application that customers are deploying on their infrastructure. So we try to keep as minimal footprint as possible. So we kind of limit what dependencies we have. We try to bundle that as tightly as possible. So it has some interesting challenges. We run, you can see, all these logos on the right. These are all the different platforms we support. There's actually been more mention of mainframes tonight than I was kind of expecting. But the image in the top right is an IBM mainframe that we have support for, all the way from that down to we have customers running our monitoring agent on Raspberry Pis embedded in their data centers and things. So it's an interesting challenge trying to support all these different platforms. Sometimes it's actually more work to get Python installed on, for example, an old AIX server than it is to get our code to run properly there. So if you're into esoteric operating systems things, there's some interesting challenges. Then finally, the last piece that we use Python pretty heavily for is all of our packaging and deployment. So we use Ansible heavily and couple that with Terraform. All of our infrastructure originally was running on bare metal at SoftLayer, and then we migrated that about 4 years ago over to Google Cloud. So we used a combination of Ansible and Terraform to actually perform that migration. So all of our production environment runs with Google, but we have some big clients that want our whole platform, which normally is a SaaS offering, to run in their environment. So we're managing both a cloud environment at Google as well as more kind of traditional bare metal deployments at a handful of customers. And we've been able to do that kind of with one set of application packages and configuration files, and heavy use of Ansible for that. So that's it. Like I said, we're always looking for good developers. Happy to talk more about any of this afterwards too.
Question. Somebody's got right here, right away.
Given that you mentioned having to support a bunch of different legacy Python versions, do you write newer code that you run when you run newer Python, or do you just have one version that has everything?
So the question is, do we write newer Python or we detect we're running a newer platform? Right now we have, for the agents, it's a single code base that we run across all of them. The agent itself we try to keep as lightweight as possible, so it's the bulk of all the data analysis and everything is happening centrally, where we use much more modern versions, but for the agent we kind of keep that as simple as possible.
And then, is there a reason why you're using threading instead of async I/O, or is that on the agents you have to use the?
So we're using threading for our network monitoring probes. Largely, that code has been around for quite a while. So we started with that, and it's working really well. Eventually, we might end up replacing it, but at this point, we have a lot of higher priority things that we're trying to tackle.
One more round of applause.